In this segment, we'd like to look at the two different types of equation, exponential equation and the logarithmic equation. The reason for that is there are times when you may have an exponential equation you're trying to solve for piece. Maybe you're solving for the power, and it would be better suited to change it to the logarithmic equation because that's its sole job, to solve for the power. Then there are times when you might have a logarithmic equation and you're trying to actually solve for a number, therefore you may want to change it back to the exponential equation. So before we begin, we should just make sure that we can do just a basic changeover between the two different types of equations. For example, if we knew that 64 equaled 8 squared, I'm saying 64 is my number, I'm saying 8 is my base, and I'm saying 2 is my power. I can rewrite this into a logarithmic form of an equation because I'm solving now for my power. The 2 would be what it equals, which means I'll take the log of 64 and have it to base 8. Of course, if I had decided to start with a logarithmic equation, let's say 3 equals log of 64 to base 4, then you'll see that, yes, my number may still be the same, 64, but because I'm using a different base, which is now 4, I know that 4 cubed, because that's my power over here, is what 64 equals. So this is just a changing of the two forms. So why do we want to learn how to switch between exponential equations and logarithmic equations? Well, if we had a problem that said 5 to the x equals 25, yes, I would like to think that you would know that the answer is x equals 2. At some point, I would rather you be able to write it as x equals log of 25 to base 5, so that your actual answer that comes out x would give you the result that you're looking for is 2. Because as we go further, 9 to the x equaling 180 is not as easy as it may seem. It is not x equals 20, and the reason for that is, there's a couple things. I happen to know that 9 squared is 81. That tells me this on the chart way over yonder. I also know that 9 cubed is 729. Also told me in the chart over here. Therefore, I'm expecting my answer between 2 and 3. If I change it to a log form, x equals log of 180 to base 9, and learn how to evaluate logs of base 9, I will be able to come up with my answer. That's not exactly the skill I want you to learn right now, because once the shortcut is taught to you, a lot of times all this is forgotten if you don't have that good foundation. But if you're determined to know what it is, x is approximately 2.364165. And as you can see, I've already got up to 6 decimal places, and it's going to keep going because it's an irrational number. Honestly, I would only have expected maybe 4 decimal places, 2.3642 as a good answer. But again, right now, that's not exactly my goal. I'm not worried about solving problems of this nature. What I'm interested in is solving logarithmic equations that I could use maybe the table over here and never even touch the calculator. So the problems I want to practice now are going to be along the lines of this. Let's say I'm trying to evaluate the log of 49 to base 7. I need it to equal something, and since logs solve for powers, I'll call it p. Well, what I can use is my knowledge of changing it back to an exponential equation, say 7 raised to the p equals 49. Realize I have all this information right here, the fact that 7 squared equals 49. I could say therefore p equals 2, and therefore I would know that the log of 49 to base 7 equals 2. Why is that important? Because not only are you learning logs, not only are you learning how to convert them back to exponential equations, you're going to find out you're going to need to relearn your exponential rules. So here's another example. Let's say I have the log of 625 to base 125. Now, if I'm going to have it equal something, I'm going to probably have to write 125 to base p equals 625. Now the first thing is I can't think of what 125 raised to would be 625, but I do recognize a few things. I do recognize that 625 is 5 to the 4th, and I recognize that 125 is 5 cubed, and then that would be raised to the p. Now that I have a common base, I could take this a step further, say 5 raised to the 3p will equal 5 to the 4th. Therefore, since my bases are the same, the only way to get this whole expression to be the same is not only the bases have to be the same, but so do my exponents. So what I've just figured out is that 3p will have to equal 4. Therefore, p would equal 4/3. So if I'm trying to figure out what the log of 625 to base 25 is, there's my work on the left, and I've just realized that my answer is 4/3. Here's another problem. Let's say I'm trying to find the log of 1/27 to base 3. Well, if I go back and rewrite it as following, 3 raised to my unknown power to equal 1/27, it would help if I had realized that 1/27 is 1 over 3 cubed. Therefore, 3 to the p, now having 3 cubed in the denominator could be rewritten as writing 3 to the negative 3. Now I have to realize I'm working with negative exponents. 3's are the same. That means my exponents must be the same. Therefore, p equals negative 3, and that's why I get the answer of negative 3. Let's go ahead and do a couple more examples of this type of problem. Let's say I happen to have the log of the square root of 7 to base 7. Then I would probably want to rewrite this as my base 7 is raised to the p, and it will produce the result of radical 7. But again, what is radical 7? If you remember that radical 7 means 7 to the half, you'll realize right away that since the bases are both 7, that means your powers have to be the same, and that means p would equal 1/2, and lo and behold, the log of radical 7 to base 7 is 1/2. Let's happen to have a problem where maybe you're saying that the log of 4/25 is now written to base 2/5. Again, if you want to have a p there, you might start asking yourself 2/5 raised to the what equals 4/25. If you realize that 4 is 2 squared and 25 is 5 squared, then you can rewrite this as 2/5 squared, and you can come up with the fact that since my now bases are the same, that means my exponents must equal each other, and therefore p must be 2. We'll do one more problem at this point. Let's go for a grandiose finish. Let's say the log of the square root of 6/7 to base 343 over 216. Well, again, if I'm trying to say that's going to be my power, then the first thing I probably should write is 343 over 216 will be raised to the p, and that will equal the square root of 6/7. Now, I'm looking at a couple things, and I realize first thing is that I can rewrite 6/7 and raise that to the half. That might be helpful. I also look at my chart, and I come over here, and I realize that 314 and 216 also involve a 6/7, and they're also cubes, but what I'm seeing now is that is actually 7 cubed is on top, 6 cubed is on the bottom. That's raised to the p, which is really close to 6/7, except the 7 is in the numerator over on the left side, but it's in the denominator on the right side. 6 is in the denominator on the left side, but 6 is in the numerator on the right side. This isn't all that complicated. If you want your 6 to move down and you want your 7 to move up, why don't you consider rewriting this as 7/6? But that means you have to take the reciprocal, and to get the reciprocal means you'll have to use a negative exponent. So realistically, this is equal to negative 1/2, which means now I have 7 to the 3p all over 6 to the 3p equals 7 to the negative half, 6 to the negative half. Of course, I could have just put these as fractions. It's 7/6 to the 3p, and equal to 7/6 raised to the negative half. But either way, what I'm getting at is 3p is going to have to equal negative half. Therefore, p would equal negative 1/2 divided by 3, which is the same as negative 1/2 times 1/3, which means your answer to this crazy problem all along was negative 1/6. And this is how we like to solve logs, using exponential equations, and more importantly, never touching the calculator. These are the kind of problems I use at the beginning of a logarithm chapter so that you don't just learn shortcuts. You're practicing your exponential rules. You're learning what logarithms are. You're understanding the relationship between exponentials and logs, and then you can build from there.